try the difficult one. Did you try it too? Okay, let's see. Consider 3 capacitors and a battery. If only C1 is connected to the battery, the charge on C is 30 microcoulombs. So if you have capacitor C1 connected to the battery, its charge, which, what's the formula for charge? CV, isn't it? C1V, that's equal to 30.8 microcoulombs. If C1 is disconnected, discharged, and connected in series with C2, when the series combination is connected to the battery, the charge is 23.1. So what they're saying is if you have 2 of them in series, the charge is CB, which is 23.1. But the C here, you have to use the formula. So you have 1 over C equals 1 over C1 plus 1 over C2. So you have V. Now let me just change this to C1 plus C2 over C1 C2. So this will be V C1 C2 over C1 plus C2. That's to equal 23.1 micro. Next, C3 is connected to the battery. C3 and C1 and the battery are connected, resulting in a charge on C1 of 25.2 Japers. If after being disconnected and discharged, C1, C2 and C3 are connected in series with another and with the battery, what is the charge on C1? I'm sorry, I think this is just way too difficult for the exam. Can we just pretend we never saw it? Is that okay with you?
It's hard, right?
Yeah, well, the struggle is good. Look, I tell you what, I will do this one. If you really want to see it, I'll do it next week, okay? But right now I'm too tired to do it, okay? Because the problem with this question is that it's going to be very long.
Well, algebra and stuff.
Yes. Yes.
That's what I thought when I did it.
Yes. Yes. But I mean, I can...
That's fine.
Well, I'll at least continue to make the equations. So what you have is here, this is your first equation, okay? And then here, this is your second equation. Now, if I go on the third equation, it says, next, C3 and C1 are in the battery are connected in series, resulting in a charge on C1 of 25.2. So now you have C1 and C3, and the charge is 25.2. So it's going to be the same deal here, except it's C1 and C3. And that's equal to, what is it? 25.2 micro. If after being disconnected and discharged, C1, 2 and 3 are connected in series with one another with the battery, what is the charge on C1? So then what they do is they put all 3 together and they want to know what the charge is. So basically we're going to need to calculate C1, C2, C3.
C1 is 30.8 over
V, yeah. Yeah. It's really, really, really long. Really long.
Pretty nasty. But if you got an answer, so I thought maybe I was just doing that.
Yeah, so if you look here, what they want is the Q here, which is CB. Okay? But the C is, it's the 1 over C1 plus 1 over C2 plus 1 over C3. so that's 1 over C, so 1 over C equals C1, C2, C3, my goodness, C2, C3 plus C1, C3 plus C2, C3. It's going to be really long to do, like really, really long to do. It'll probably take me about 15 minutes to do it. Yeah, it's way too difficult for the exam, just way too difficult. But next week, if you really, really want to see it, I'll do it next week.
I feel satisfied now.
You feel satisfied enough?
It wasn't straightforward.
Oh, it's not straightforward.
I thought maybe I was just doing something really stupid.
No,
I don't know.
it's very difficult. It's very difficult. Were you able to get 1 to 7?
Everything but 9.
Yeah, well, if you got everything except 9, then you're doing exceptionally. What about for you, Abraham? Yeah.
7.
But do you think it's okay, or do you need to see it? Well, we do 7 really quick. 2 capacitors give an equivalent capacitance of 9 picofarads when connected in parallel, and an equivalent so what they're saying here, Abraham, is when you put the capacitors together like this, and when you put them together like this. In this picture here, when they are in series, you get 2 picofarads, and then here, when they're parallel, you get 9 picofarads. That's what they're saying. So you have the formula C1 plus C2 equals 9 pico. And then here you have 1 over 2 equals 1 over C1 plus 1 over C2. And what they want is the C1 and the C2. So, do you want me to continue, or did you get this?
Yeah,
you got this, but the next part's the problem.
Yeah,
okay, so I would say this is C1 plus C2 equals 9 pico, and then this is 1 over 2 equals C1 plus C2 over C1 C2. So here this is C1 plus C2 equals 9 pico, and here this is C1 C2 equals 2C1 plus 2C2. Yeah? Oh, I did? I added these together. I put these together. You know, A over B plus C over D is AD plus BC over BD. That's a D. Okay, that's what I did. And what should I do next here?
C1 plus C2 is 9, so you put 9 exactly.
You could say C1, well I would say C1 equals 9 pico minus C2. Yeah? And then you can put that in there for C1. So then you get 9 pico minus C2 times C2 equals 2C1 plus 2C2. So you get 9 pico C2 minus C2 squared equals 18 pico minus 2 C2 plus, oh that's great because then they cancel, so you get a quadratic C2 squared minus 9 pico C2 plus 18 pico equals 0. Close.
It's plus 18.
Yeah. So, what do you get here for C2?
Yeah, C2 minus, it looks like C2 minus 6 and C2 minus 3.
6 and 3?
Yep.
C2 minus 6 pico and
C2 minus 3.
yeah.
And that basically gives you the answer.
Yeah, because you have here, you can get the C1 from this. So if you have C2 equals 6 pico, then C1 will equal 3 pico. And if you have C2 equal 3 pico, you get C1 equals 6 pico. Which is not surprising because the reason for the two answers just means you have 6 and a 3 or a 3 and a 6. It's the same thing really. Is that okay, Abraham? Yeah. So the problem was really solving two equations, was it? Yeah. Okay, if you write this down, we'll go on to the next topic. Unless there's something else to see. Is there? Because the next topic is really important, what I might do is spend half the class today, the rest of the class today, and some of the class next week, because it's such an important topic. Kirchhoff. Do you know this name? No. It's such an important topic. It's nice question in the exam. It's not difficult to do. You can get full marks in it. It's a good question. So I want to give it some time. That's yours. Okay. Did you write this down?
Yes.
So how are these for you, Louise?
No.
Was it problem?
No problem.
Oh, no problem. Okay, so you did 1, 2, 3, 4 then, was it? Okay. What about this one?
I'm not doing it.
Okay. Can you mark this one? It's important that you do these diagrams, you know what I mean? So here you have 1 over C equals 1 over C. You know the two rules I'm talking about? Yeah. So you need to use both these rules here for this, yeah. Make sure you try to do this one and maybe this one too. Yeah? Okay. Can I go down? Okay. So this next lesson is all about Kirchhoff and his rules, Kirchhoff's rules. So I'll tell you something first before we start. When I was first teaching physics here, this topic was my least favorite topic. I didn't like this topic, okay? But after doing it a while, it's now my favorite topic, okay? So I'm just saying, at first, you might not like it, but I do think it's a good topic. Okay. So Kirchhoff has two rules when he's talking about circuits. So this is his first rule. So what I'll do is I'll write the rule down and then I'll explain what it means. So Kirchhoff's first rule, rule 1, or first rule. This rule is also called the junction rule. And his rule says the total charge at a junction must equal 0. So that's his first rule. And now I'll explain what this means. Do you have this? Yeah? Okay, so this is what his rule means. When you have a junction is when your connection breaks, like this. Or more than half, yeah. He says the current that goes into the junction must equal the current that goes out of the junction. So in other words, you can say I1 must equal I2 plus I3. Or, if you try to make it equal 0, we write it like this. I1 minus I2 minus I3 equals 0. So in other words, the current that goes in minus the current that goes out, that should equal 0 at a junction. So if 1 amp goes into a junction, then 1 amp must come out of the junction. So do we understand what I'm saying here? Is it clear or not clear?
Not clear.
Not clear. Which part is not clear?
Can I check what is junction?
No, you can't. I'll tell you what junction is. But before I do, Louise, question?
Actually, the 3i also is same.
No, maybe it's different to I2. So when you say the 3i, do you mean this or do you mean all three?
All three.
These can all be different. So I'll give you an example. Look, here is maybe 5 amps. Okay? What I'm saying is the total here that comes out must make 5. For example, 2 amps maybe and 3 amps maybe. That's what I'm saying, that the current that goes in must equal the current that comes out. And who? Junction. You see this road here? This is a road, and this is a road, and this part here is called a junction. So a junction is where two things meet. Yeah?
In the future goal.
Yeah, basically that's splitting on.
They do meet. These two meet this one here. Yeah? No? Yeah?
Like a junction.
The junction down the road, yeah.
Right there.
Go have a look, yeah. You know what junction is?
Yes, I know.
You know junction?
Yeah, like right there. You see where the operator
Yeah.
is on without it. Right there, that's probably the two main junction.
Who? Hey, use your dictionary if you want, it's okay. Alright, so that's his first rule, okay? So now here's his second rule. Second rule, also called the loop rule. And his second rule says the total voltage around a loop must equal 0. So can you write this down? And then I'll show you what that means. Yeah? So, can I go down? So his loop rule says this. If you have something like, I don't know, like a resistor here, and a resistor here, and then like a battery here, this has a voltage, that's called a voltage V1, and this has a voltage, we'll call it V2, and this has a voltage, we'll call it E. His rule says that E must equal V1 plus V2. Or, if we write it with a 0, E minus V1 minus V2 equals 0. So the voltage provided minus the voltage used must equal 0. And loop means this. This is called a loop. When you go around in a shape, like a square or a circle, and you go back to the start, that's called a loop. So this is Kirchhoff's loop rule. We're happy with loop? Did you find junction?
Yeah, I know what the loop of.
You know junction?
Yeah, in Chinese.
In Chinese, yeah. Do we have this? Okay, I want to do some examples, so let me just open up a diagram. So these rules, they seem pretty simple. You know what I mean? That it just says the current that goes in must equal the current that goes out, and the voltage you use in a loop must equal the voltage of the battery. Yeah? So let's have a look here at some examples. I'll try and get you a diagram. Let me see. Questions. Then let me just try and find it. Loading. too easy. Ah, yeah. Here we go. Zoom in. Whoops, too far. Okay. Right, so here in this diagram, it looks quite complicated. You have a battery here, you have a battery here, you have 1, 2, 3, 4, 5 resistors, and you have a current here, I1, a different current here from this battery, I2, and then these two currents combine and go down here in the middle to make a new current, I3. So what we want to find is I1, I2, and I3. That's what we want to calculate. Okay? So firstly, let's draw this. So can you just draw this diagram first? So draw this, please. Can you see it okay? Yeah? You got it? Yeah? So let me just see, this is 11, 12, V1, 5. Okay. You have this drawn? Yeah? Okay. Whoops, wrong one. 11, 12, V1, 5. 11, 12, B1, B5, oh second, sorry. Okay, so let me just try and copy the piece I care about, which is here. See if I can paste it. No paste. Hang on. I was hoping I could just paste it. Alright, I'll have to draw it. Alright, so you help me. What do I have first? Well, let me close this. Discard. Okay. So it's battery. Okay, so if you help me out here. So first the battery. How big is the battery? 50. Okay, and then there's a resistor. Yeah. 10 ohms, and then it turns a resistor. 5 ohms, and then there's a resistor again, and it splits.
That's 4.
Which the one on the top? This is 4. Okay, and then this one. 2, and then there's one here?
Yeah,
3 ohms, and then where's the battery? Under the tree?
Yeah.
And which way is it going?
It's
it's the same direction. Okay. Oh, sorry, did I draw my battery the wrong way around? No, okay. So there's this one here, and how big is this battery? 4 volts. And is that everything?
The currents.
Oh yeah, well I'll do the currents now, but that's all the resistors and things. Right, so this battery here has a current of I1, and here is I1, and then here is I1, and then this battery here is I2, and then it's I2, and then it's I2. But then what happens here? They combine to make a bigger current, I3, and then I3. What current do I have here? Here. I2. Here's my little tip, okay? If I2 comes out of the battery, then I2 goes into the battery. And here I have I1, because if I1 comes out of the battery, then I1 goes into the battery. Okay, so this is the diagram. How many junctions are there? Very good, 2 junctions. So first we use Kirchhoff's junction rule. So if we use Kirchhoff's junction rule here, what currents are going into the junction? I1 plus I2. And what is coming out of the junction? I3. So you have I1 plus I2 minus I3 equals 0. Firstly. Okay. Next, we use Kirchhoff's loop rule. How many loops are there?
3.
2 or 3? Louise says 2, who says 3? Ibrahim? 2? You go? No, what? 1 now, or we're going down. 2, you changed your mind? I shall tell you, you were right the first time, it's 3, okay? I'll show you the 3 loops. Look carefully. Here's the first loop. This is loop 1. Okay? This is loop 2. Okay? And then this is loop 3. So you have 3 loops. Now, how many things are we looking for? How many things do we want to find? 3. We want I1, I2, I3. Yes? How many equations do I have so far? Just 1. So how many more equations do I need? I need 2 more, yeah. So I need to use the loop rule twice. Which 2 loops do you want to take? You can take any loops. Which ones do you want to take? We have 3 loops. Which loops do you want to use? We have small loop, and then big loop. Which ones do you want to take? I think yes. I think I would use the 2 small loops. Okay. So watch. This is how we use the loop rule. So first you start at the battery always. That's just my advice to make it easier. We start at the battery. What's the voltage of the battery? 50. Now there's a voltage here, but we don't know what it is. But we can find it if we use Ohm's law. What's Ohm's law? V equals I or. Do you know the I? Yeah, well, I mean it's I1. Do you know the or? Yeah, what is it? 10. So what's the voltage here? 10I1. Can you see why it's 10I1? You look confused, Louise. Can you see why it's 10I1? Yeah, so you look here. You see this formula? The I is I1. And the or? 10. So what's the voltage? It's 10I1. What? No, it's just 10I1.
Sorry.
Yeah, 10I1, because we have 10 for or, and then I1 is the current. Tell me, Louise, what is the voltage here? Yeah, the voltage, the V, for this one. What do you think? Go on. 5 what? 5 something. 5 I1. What about this one here? What is it?
I2.
Good. This one?
3I2.
Good. Ibrahim, Surprise change. Give me this one here. What's this one? 4 3. So we know how to get the voltage in each one, okay? So we start here at the 50, and then we go around the loop. Okay, 50 first. This one, do we use voltage or do we get voltage? We lose voltage. We use it. Minus 10I1. Here, lose or get? Lose. How much do we lose? 5I1. Here? This one? Lose. How much? 4I3. And then finally we're back at the start, equal 0. So we have 50 minus 15I1 minus 4I3 equals 0. Are we okay with that? Yeah. So now we'll go to the next loop. So the next loop we said we'll use is this loop here on the right. So we start at the battery as normal. What's the voltage of the battery? It's 4. Minus. Now here, this is 3I2 minus 2I2 minus 4I3 equals 0. We went around this way. Okay. So we get here 4 minus 5I2 minus 4I3 equals 0. I'm just going to move this box over here. Okay, do you have that? You got that? Yeah, okay, so now we need to solve for I1, I2 and I3. Can I move to the right? Ibrahim? Is that yes, no?
Yes.
Yes? Okay, so if I go to the right here, and I think substitution may be, yeah, sorry, this equals 0. Here I can say I1 equals I3 minus I2. And I can put that in here. So I get 50 minus 15 I3 minus I2 minus 4I3 equals 0. So I have 50 minus 15I3 plus 15I2 minus 4I3 equals 0. So I get 50 minus 19I3, sorry, write that a bit clearer, 50 plus 15I2 minus 19I3 equals 0. Now what I'll do next is I'll multiply this by 3. So if I multiply this by 3, what do I get? I get 12 minus 15I2 minus 12I3 equals 0. Now that's really good, because what should I do next? Yeah, I can cancel these by putting them together. So if I add them, yeah, I get 62 minus, what's it, 31, I3 equals 0. So I3 is roughly about 2, is it? What is it? Oh, it is 2, not roughly 2. It is 2. So we know I3. No, can I find I2? Yeah, I can just put this back in here, we'll say. So we have 4 minus 5I2 minus 8 equals 0. So I get minus 4 equals 5I2. Is that right? So I2 equals minus 0.8. Now don't worry about the minus, I'll talk about that in a moment. So we have I2 and we have I3. And finally I can get I1 by using this formula. I1 is I3 minus I2, so that would be 2.8. I1 equals 2.8 amps. Okay. So you can see that this really is more a mathematical problem than a physics problem. Maybe that's why I like it. You know, it's a math problem. What does it mean though if the I2 is negative? Does anybody have any ideas about what that means, that my I2 answer is negative?
Direction.
The direction, yeah. Because the I2 answer is negative, it actually means that the arrow is the wrong way. It's actually going to the right, not to the left. So if you have a negative answer, it just means it's going the other way. That's all. Okay. In which direction will the electrons flow in the 4-volt battery? So because I2 is negative, which way is the current going? It's going to the right. Yes? So the current is going down. So which way are the electrons moving? Up or down? Up. So if you forgot, that's okay, but just remember, if the current goes from A to B, it means the electrons are moving from B to A. So in this picture here, the current is going down, the I is going down, so the electrons are moving up. Okay. I don't know, I did say that last week, I don't know if you remember it. So if the current is going this way, then the electrons are moving the other way. Okay? The opposite way, yeah. Don't worry, you'll forget that again. Okay? But just try to remember it. Current is this way, the electrons are actually moving backwards. Okay. Now, we have this question finished. By the way, this is an exam question, that's why I have it here. And it's quite nice because I think the marks here would be 3, 3, 3, 1. So this question here is 10 marks, which means it's 10%, which is a lot for the exam, 10%. Okay. Now, what I want you to do for me now with this question is, I want you to use Kirchhoff's loop rule for the big loop. I want to see what equation you can make if you use the big loop. Okay, do you understand? We don't need to do it because we finished it, but I want to see if you can make the loop equation for the big loop around the edge. And then I want to see what you got. So I want you to make the loop around the edge. I want to see what you do. I want to see how you think. Which one are you doing now? Which way are you starting? The 50, yeah, okay. Okay. I don't need you to do this one. I just want the loop. Yeah. Yeah, the 50 one. Yeah. Okay. 50. Yeah, go. Let me see. Do you know what to do it?
No idea.
You've no idea. He has some idea. Why don't you copy him? Yeah. So far, so good. No idea. Okay.
All this one.
Which one is that? Is that this junction?
Here.
So you're starting here at the 50. Yeah? You're doing the same thing as Abraham. I don't need the junction rule, I just want the loop rule. So just you can scratch that out. So start here with 50, so 50. Okay, and then I want you to go around like this. If you want to draw a picture, I don't mind. Yep, minus, not minus. You lose voltage here. My question is make the equation for the outside loop. That's all. Don't solve it, just make it. Good. So far so good. Continue. It's nearly the same, except I want you to go around here. I'm not going to tell you yet. This is the thing. Hugo, how are we doing? You got an equation or not? Let's see. Good, I'm happy. I tricked you. So, they said the numbers are right, but some of the signs are wrong. Okay, I think I looked at people here, let's have a look. This is something different, that's okay. So I looked at people, and it seems like you have an idea, but I'm happy that you didn't do it perfectly. Yeah, but I wanted the I's and the R's. Yeah. Good, not perfect. Bit like Hugo. So you have the right idea, but... Huh? Well, I'm going to do it now anyway. So, let's have a look. Okay. So I'll just go back to my picture here. Where's it gone? Here it is. Okay. I'll write the equation up here. So we all start at 50. So I think everybody has 50, yeah? And then what happens here? We do minus 10 I1. Yes? I think you have that, Abraham, as well. And then what's next? Minus 5 I1. Okay. And then what's next? Ah, good. I tricked you. It's plus 2I2. Now why is it plus? Why is it plus?
Minus 2.
Yeah, it's minus 2. Because if you look here, look, the current is going the other way. So it's a minus, as you said too. What about this one? Very good, plus 3I2. Now, what do we do when we get to the battery here? Plus 4 or minus 4? What do we think?
I think actually it's close.
Yeah? You think plus?
Oh no, wait.
Or maybe minus? Well, let me help you. It will be minus 4, and then we have equals 0. But why is it minus? Look, if you have this battery here of 10 volts, and this battery here of 5 volts, what's the total? It's 15 volts. But if you put your battery in backwards, like this, if this is 10 and this is 5, they don't add together. Instead, this battery interferes with this battery to reduce, not increase. So what would it be here? It would be 5, because it takes it away. So if I look here, are these batteries connected the right way or the wrong way? The wrong way, because if you look, it goes positive to positive, where if you want to add them, you want a positive with the negative for the batteries. So that's why it's minus here. Now what happens if I take this battery, look, if I take this battery and then I turn it around, what would happen? Then it's plus 4, because then you get 4 volts more. So you add the 4.
Does that also affect the CI2?
Yes, you can still keep your I2 drawn as it is, but the answer will now be positive. If you think about this for a moment, this battery is much bigger than this battery. Here we said that I1 goes up, and here we said the I2 goes up. But I2 was negative, remember? So that means it actually goes down. So why does the current go the wrong way? Because this battery is so big. What happens is the I1 comes along and then pushes the I2 backwards the wrong way. That's why the I2 is negative, because this battery is so big. If I make this battery really small, like 1 volt, then what would happen is this battery would push the current through this battery, and so the I1 would be negative. Now, you don't need to worry about that. I'm just talking about it for ideas, okay? Really, for these problems, it's all about making the equation and solving the equation. So this is why I like the question in the exam, because it's very clear. You have a picture, you make the equations, and you solve the equations, and that's it. So this is why I like it. So they can be long to do, but they're not too difficult to do. Now, I said this is very important for the exam, so what I was thinking was, I have some of the diagrams here. So what we might do on, when's our next physics class? Wednesday? What I think I'll do is, we might spend some time doing these in class after you try them at home. Okay, because they're important. I think these are okay. They're not too difficult. They're about the same as this. So if you're okay with my example, you should be okay with this. All right. Have a look at them. Now, just notice, please. If you look at the first question, sometimes they tell you the current, like in question 2, and in question 1, do they draw the current? No, so you have to draw the current. So, for example, you have an I1 for the first battery, and then you have an I2 for the second battery. So you need to draw the current in.
It can also feature from myself.
Sometimes yes, sometimes no. Before you go, can you just draw the current on the diagram? I want to see what you draw. Yeah, so I just want you to draw in I1. So this is I1, so that's I1. Oh, you can call it I1. You can call it I1. And then this one here is I2.
How about this one?
Yeah, how about it? What do you think? This one. Maybe I3, yeah. So here, this is I1. Oh, you can call this one I1, I2, I3. It doesn't matter. I think maybe you're right. Maybe you want to call this something like I3. Because if I look here, this one comes up here, and then this one comes up here, and then they come together to make a new one, I3. So yeah, here is I3. Yeah. So I1 is here, I2 is here. What about here? What comes here?
I want this one is I2.
No, this one's I2. Because here's I2. It goes I2, I2, I2. It changes here, yeah. After the junction it changes. Because it combines with I1. I1 and I2 come together here, and then they make I3.
How about this one?
Here's here is I3, and here's the junction. Yeah, what happened is it was split back to I1 and I2. Because this is I2 here, so it means here is also I2. It doesn't change until it gets to the junction. Yeah. Can I see what you drew? Yeah, and there's also an I3, which is on this one. Is I3. Yeah, here, on this one, yeah. Doesn't matter if it's up or down. Yeah, you go down, that's fine. Okay, we better finish now because we have maths in a few minutes. Yes? You want me to check? Yes. Okay. Can you try to do those 7 questions for Wednesday? Okay? And then on Wednesday we'll do them some of them in class. Right, try your best. Try your best.